All right, all right. Gotta get day 5 up and running here. So for day 4, we had a lot of this passport parsing. See, I wonder if there's going to be a continuation already. In some of the previous ones, there were, I don't know, there were sort of like a series of puzzles where one puzzle may have been partially based off of a previous one. So you may had to have refer back to previous work to solve a problem. What am I doing? Text file. 05. Okay. Well, that should be it. Get me ready here. About 3 minutes in. And what do we have here? We have, what is this? Maybe a line to the North Pole? Or is it South Pole? North Pole? You know, I'm not sure. Yeah, I wonder. So far, so good. 1 through 4 wasn't too bad. I'm doing something about going through an airport. What am I doing? You save Christmas 5 times in a row. We're taking a vacation to a tropical island. We're finding gold coins called stars. You'll need at least 50 of these coins by the time you arrive so you can pay the deposit on your room. Okay. So the entire trip, the entire plane trip, I'm supposed to be collecting stars? So the first one was what? Everybody getting stuck trying to figure out passports. 2 was password database. Toboggan login? So we have to take a toboggan to get to the airport? I guess that kind of makes sense. What are we coming from? Where the heck is Santa from? The South Pole? Alright, we arrived at the airport via our toboggan. Oh, I guess the North Pole. Let's see, North Pole credentials. So we had a mix-up between our super secret Santa ID and our actual passport, which apparently we need to go from a secret airport to some island. Yeah, we'll see. So, almost here. 5 seconds. See what we got. Board the plane. Write a quick program to use your phone's camera. Instead of zones or group, this airline uses binary space partition to seat people. Seat might be specified, such as this, where F means front, B means back, L means left, R means right. The first 7 characters will either be F or B, and these specify exactly one of the 128 rows on the plane, numbered 0 through 127. Each letter tells you which half of the region the given seat is in. Start with the whole list of rows. Binary space partition. The first letter indicates whether the seat is in the front, 0 through 63. Oh, so I guess it's like a binary search. And you're moving top to bottom, left to right. F or B. First 7 characters will either be F or B. Front, back. So we're going to go up and down until we get to our row. And then we're going to go left and right until we get to our seat. So I guess that makes sense. F means take the lower half, keeping the rows. Upper half, lower half, upper half. B means rows 44 through 47. F keeps rows 44 through 45. $63, okay. The first 3 characters will be, so first 7, front, back, last 3, left or right. You specify exactly one of the 8 columns of seats on the plane, numbered 0 through 7. Same process as above, proceeds again, this time with only 3 steps. Left, lower half, right, upper half. So decoding this, row 44, column 5. So let's start, this one's kind of complicated, so I do want to start with the test data first. What is the highest seat ID on a boarding pass? How do you get the seat ID? Multiply the row by 8, then add the column. This example, C is 44 times 8 plus 5. Okay. All right, so day 5, let's start parsing these. Let's just turn them into a character array. What is the highest seat ID on the boarding pass? Okay, so for each seat, we need to start doing our binary partition thing. So 0 through 127. So we need to go through 0 through for 7 characters. So if we go front, we need to take the lower half. So we should get, we want 63. The not find the file 05. Oh, didn't name my text file correctly. This is another one of the things that messes me up is how these whoops. Want to make sure that, yeah, that it goes to the proper number. Let's see, if we take the upper half, what do we need to do? We should go to the lower half plus 1, I guess. 32 through 37. Or I guess do nothing? Upper half, 47. The lower of the two, 44. So I guess we only want to do the first 6. And then for seat 7 or item 7, we will subtract 1. Row 14. Not even close. Let's see. Consider the whole range. F takes the lower half, 0 through 63. B takes the upper half, 32 through 63. Oh, I do need to restrict the lower bound. How do I do that? Yeah, this isn't how I should be doing it. I should have... Guess I should have an upper bound and a lower bound. If we're taking the lower half, we need to restrict the lower bound. Else we need to increase the upper bound. We do that by adding half of the lower bound. Or, no. We need to increase the lower bound by adding half of the upper bound. So what did we get? 77 and 15. Row 70, column 7. So when we're taking half of the upper bound, we need to use a ceiling. What? Jeez. All right, so 80 and 15. We're just not getting any closer to doing this properly. So let's see. Let's do this one. And step through it. All right, so for step 1, we got 0 through 63. Step 2, 32 to 63. Ooh. Step 3, we got 32 to 31. Because we need to take half of the range. So it should be upper bound minus lower bound divided by 2. 0 to 63, 32 to 63, 32 to 15. What is this supposed to be? Minus equal? 32 to 64. 32 to 48, almost. So 32 to 64 is incorrect because I think we need this dumb ceiling thing again. Upper bound minus lower bound. Zero to 63, 32 to 63, 32 to 47. Okay. And then the final row should be the minimum between these two. Keeps the lower of the two, 44. What are we, 6? If 6 equals F, we'll give the lower bound. Otherwise, give the upper bound. So we get row 80, which again is not even close to being correct. Lower bound was 80, upper bound was 63. How did that happen? Let's try this again. 0 to 63, 32 to 63, 47. Now the lower bound went from 32. Oh, again, it needs to be the difference. There we go. All right, so we got the correct row. Now we need to get the correct seat. The whole range, 0 through 7. 4 through 7, 4 through 5. Upper bound, no, it's lower bound. Column, upper bound column equals 0 through 7. Last 3 characters. So we need to check the first 2. And do pretty much exactly the same thing. Except this time it's R and right and left. And we need to do lower bound column, lower bound column, lower bound column. The last seven, 6, 7, 8, 9. going to take the smaller or the greater of the two. All right, see how that worked out. What do we have? We have 44 for column and 6 for column, 44 for row. That's not correct. Column 5. So let's step through this again. Four through 7, which is right. Then 6 through 7, which is not right. Bound column, lower bound column. Right and left. Why didn't we take... What are we on right now? Oh, that's because you're not doing this correct. We need to start at... What are we starting at? 7? Not right. Let's step through that again. Zero through 3 and 0. What am I looking at? 0 to 3. We're looking at R, RLR. Did I mix these up? I did mix these up. This should be R. And that gives me the correct column. Then I need to calculate the seed ID by row times 8 plus 5. And we'll take the max seed ID, max ID. So let's see, we get where's seed ID? 357 for this one. And then 567, yep. 119, correct. 820, correct. Okay. All right, so we can finally grab our puzzle input. And return max ID. Max ID 989. Oh, got it right. So We get to find our seat. It's only took us 25 minutes. All right, full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in your list. Completely full flight, so your seat should be the only missing boarding pass. +1 and -1 from yours. Okay. So we need to create. We need to go through each seat. Let's see. What am I doing here? I need seats that are IDs +1 and -1 from yours. How would we find that out? There's got to be a trick to it. Can I not? Cannot apply indexing on a sorted set. Fine. The song. Would that work? No, apparently not. It said that the seats with IDs +1 and -1 from yours will be in your list. Hmm. Oh, am I not? Am I not adding my seats to this list? Really? What the heck? What was I doing? 988. Is that? Wait, what? What am I doing? What is the ID of your seat? Is it really 988? $988. So my list of seats, you tell me at the... These seat IDs are all subsequent. Oh, that's because I'm not even... No, I'm calculating it. Row times 8 plus column. So why are they all +1? Let's see. So your sheet should be the only one missing. Oh, okay. That's the clue. What do we need to do here? I think that's it. So found seat 549. Let's take a peek through that list just to make sure. 549. No, our seat should be 548. Okay. Let's throw that in there. There we go. Ah, man, that was they're getting harder. Ooh, harder for other people too. Oh, no, wait. I got a terrible score here. Lot worse than I've done before. Yeah, it just took way too long to figure that one out. I mean, it seemed pretty simple. You just take the lower bound and upper bound. That lower bound thing was kind of confusing. I guess it did kind of explain it. It did say that it was a, what did it say? A binary space partitioning. I guess I should pay attention to that. Yeah, it's just tricky. Well, at least I was able to put in the answer and not have to go back. I got the answers correct the first time, I suppose. It just took me longer to come to that answer. Still had to do a lot of debugging, I suppose. Let's see. In the second answer, yeah, looks like we're not figuring this out very efficiently. We shouldn't have that 1 millisecond. So, however we did solve number 2, there's probably a much better way. Yeah, I wonder. I guess we could maybe sort. No. Yeah, I don't know. All right. Well, that's it for this one. I guess we'll start seeing them get longer and longer, as we've seen so far. All right. That's it for this one.